Today I'm going to teach you how to find the domain and range from a graph. And the first question you might have is, what in the world is a domain and what is a range? And that's a very good question. Basically, they're each titles of lists of numbers, but very special lists of numbers. To kind of get you eased into that, let me start with animals. Here you see some animals, and I hope that you can categorize them into two different animals. On the left side, we have cats, and the right side, we have dogs. Cats and dogs are titles of a list of a type of animal, just like domain and range are just titles of list of numbers. So let's go see what type of numbers we're talking about. Hopefully by now, when you talk about the coordinate plane, you know that the ordered pairs are the x values and the y values. And those correspond with the x-axis and the y-axis. The first number being your x value and the second number being your y value. So basically a domain is just the list of all of your x values from the dots that are on the graph. And the range is just the list of all the y values. Here I have rewritten all of the ordered pairs, and I'm showing you with the arrows that the first number of each ordered pair is just in the list called domain, and the second number is in the list called range. When you write your numbers in the domain list and the range list, a lot of times we put them in little curly brackets like this. And when we do, we put them in order from the smallest number that showed up in the list to the largest number that showed up in the list. And so for my domain, I have -4, -3, -2, 2, 3, and 5. Now you might be looking over at the range and going, you missed a couple. Well, I didn't. Here's why. When you're listing numbers in order from the smallest number to the largest number, you never repeat a number. You kind of get rid of the duplicates. And so I have 2 2s and 2 -2s, and I'm only going to show them up once. Here, let me use my cats as an example as to why. Let's say I'm showing you a lot of pictures of my cats, and I show you these 4. Well, I only have 5 cats. Can you see the duplicates? Yeah, this down here, this is funny little Lola. She shows up in the picture of the 4 of them, and this very funny guy is Rudy, and he shows up also in the picture of the 4 of them. So when I would be listing my cats, I would not say, well, here's Rudy, Lola, Lola, Mimi, Casey, Megan. I would just say their name once. I'm not going to repeat it. And that's the same thing with your list, your domain list and your range list. If a number shows up more than once, you're just going to say it once. Do you see the difference between this graph and what we just had? What we just had is called a discrete graph, which is just basically points on a graph. This is called a continuous graph because it goes through basically an infinite amount of points from the first dot you see there on the left to the last dot you see on the right. So for this, we use compound inequalities for the domain and the range. So let me dig a little bit deeper into this whole continuous graph. Not only do we have a point where I believe that's -4, -2, but we also have a point here on the line. I made it a little bit bigger. And we have a point here, and here, and here. In fact, not only do we have points there, but we have points between those points, and between those points, and between those points, and between those points. In fact, there is an infinite amount of points between those two dots. And so you and I, we don't have enough time to sit there and write an infinite amount of numbers for the domain and for the range. So we have to kind of find a shortcut. And that's why we use compound inequalities for graphs that look like this. Now, as a reminder, the domain is a list of x values. And so I can show you this a couple different ways. The first way is just showing you some numbers. This right here is -4, -3, -2, -1, 0, 1, 2, 3, 4. And basically our graph is going from -4, to 4. And so I can just write this -4. And I'm going to talk about that greater than or equal to. In this case, do you notice how the dots on both of the ends are closed dots, which is why I have the equal to. Let me show you another way. Here's a visual way to see the domain. Now, x values go left to right, and so that's one of the things that we use to help people remember is we're going from the numbers left to right. And here I've shaded from the most left, which this is at a -4, all the way to the most right, which is a 4. And then X is everything in between, just like our inequalities that we've done before this. And so this is exactly the same inequality I just did on the other screen, but that might be a better way or an easier way for some of you guys to see the domain. The range is all the Y values. And so as I look right here, what's the highest this graph went? Looks like a 3. And then if we just write these numbers, and remember we're going to go into the negatives here, and that's the lowest. So basically here's the lowest, here's the highest. And when we're writing a compound inequality, we always start with the smallest number. So I'm start with -2, it's greater than or equal to, because again, we still have those closed dots. But here's important, range is your Y value. So I'm going to put a Y right here. And then less or equal to 3. So basically, this graph goes from -2 up to 3. Let's look at it with the shaded box. I've shaded the values from the bottom to the top, and that's a good way to think about the range. The range is the bottom to the top, and I could say top to bottom, but because we're going to do our inequality from the smallest number to the biggest number, thinking of it from bottom to top kind of works a little bit better. And our bottom, our lowest area is -2, our highest one is 3. And so I'm going to write that, the same exact inequality that I just did. -2 is less than or equal to Y, which is less than or equal to 3. Those are just a couple of different ways to look at it when you're looking at a graph. All right, it's time for you to practice finding the domain and range from a graph. Go have some fun.